I'd like to start with a brief anecdote. About 5 years ago, I was working at a satellite uplink facility not too far from here. And we were, as consultants, coming in and working on site there at the client site. And we would arrive early in the morning to beat LA traffic. So we arrived 5 a.m. and this particular morning, the overnight engineer met us with a panic. They had an outage and they were trying to restore these services. And while they're looking through the racks trying to resolve this problem, they found that the documents that they had, the drawings, did not match the reality of the rack. They had an old version of a drawing. And so they were stuck. And so when we arrived, our team arrived, we were able to find the current version of the drawing, get them unblocked, help restore the services. And luckily that situation was resolved before the real morning started. Of course, that company does have someone who manages the documentation and documents, but they don't arrive till 9 a.m. So luckily we were there to be able to help. Sadly, this is something that happened all too frequently. It was a fairly common occurrence. And I'm here to talk about the ways that I think that these issues can be better addressed. And I went on a search after this incident and others to look for better ways to document systems. And I think I've found some good solutions over the past years. My name's Lukas Odhner with NTC. Almost exactly a year ago, we were acquired by Deloitte. So I'm proud to say I'm here representing the Deloitte Media Solutions team. Unified system design. This is a term that we've coined to describe what we're trying to do in terms of improving documentation standards in a number of different ways. So what is unified system design? We've given it 4 qualifications, I think, to call something unified system design. The first one is that you're storing your design data in a database. The second qualification is that you are including aspects of physical design, so cables, racks, sites, things like that. Third, and this is just becoming more and more and more important every day, is storing the logical data correlated to the physical data. I'll get into that in a moment. And finally, including a drawing library. I believe this is an important part. Drawings are sort of foundational to this industry and how documentation has been done. I think that there's still a very important place for that in this future design solution. So when I started out on this journey to try to find a better solution, the first tool that I came across was an open source project called Netbox. It's started by a guy named Jeremy Stretch. This is fairly widely adopted currently in corporate media, corporate IT. And so what we did is take Netbox and make some adjustments to it to tailor it specifically to the broadcast and media industries. And we call our version of Netbox NDocs. And so as I began this, one of the things that I asked myself, or that the team asked ourselves, was why do we document in the first place? And I believe there's 3 answers to that I'm going to cover today. The first answer is that we document to build media systems at scale, large facilities, or other systems. The second reason, we document to communicate the changes to those systems that happen over time between different teams. And third, we document to understand the way that those systems are supposed to function and help promote understanding among the people that are responsible for operating and using those systems. So, starting with an example, in a recent esports project that we undertook using these design approaches, we were able to accelerate the procurement process significantly. We were able to do this by adding devices to this unified design database as soon as the decision was made that they were going to be used, rather than using a traditional sort of waterfall design approach where you're waiting for every design decision to be made before you place an order. So being able to track the procurement along with the design sped things up. We think that we saved maybe 6 to 8 weeks overall. And This is especially important in obviously today's climate situation where there are supply constraints, and so the sooner you can put in orders, the sooner you can complete your project. The next way that we were able to accelerate the build of this facility was with some sort of innovative logistics processes. So we had pre-printed stickers for this facility, and we're actually building another facility very similar, and we just printed thousands of stickers for all of the devices that are being ordered and are coming in. So the logistics team will take the sticker, attach it to the device, and maybe it's a switch or whatever, and that sticker has, of course, the manufacturer and the model of the switch in this example, the room that it would be placed in, the rack, right down to the rack unit. And this has a couple benefits. The first is that devices get installed the right place the first time. But then the second benefit is related to this QR code. So that QR code, when scanned on a phone or iPad or a laptop, will take you to a page where and so we would use little QR code and barcode scanners, and then it takes you to a page that where you can input the asset tag, serial number, and allocate that device as soon as it arrives. And so that allows that information to flow back to the program management and help track devices as they're installed, as they're allocated, and then all the way through as they're tested and eventually put on air. The next way that we're able to improve install processes is the cabling. As anyone that's worked in a large facility knows, this is where there's the most to go wrong. It can be a challenge to get thousands of cables installed. In another recent project, we had 20,000 cables that need to be installed in a very short time. And to further complicate that, there was 3 contractors responsible for installing. One contractor doing horizontals, another contractor doing the broadcast-specific sort of consoles cabling, and then the third one that was doing work in a data center. So using this unified database, we were able to sort through the cables, track their progress, and really just keep this complex cabling system on track. But perhaps the most powerful reason, and the reason that you should store cables in a database rather than a spreadsheet, is the ability to trace cables from end to end, so multi-segment cables. This is a view of what the cable, cable list would look like. But so to trace cables from end to end, this is an example of you click on a cable and you're going to trace it through the entire pathway. And this might be a patch cable going over a fiber trunk, going to another patch cable. And this has 2 benefits. One, of course, if you're trying to do the actual installation and you're trying to troubleshoot the cables, why you don't have a link light, it can be very useful to have this. And the second reason that I'll get to in a bit is this unlocks the ability for some automated configurations, automated switch configurations. So these are the reasons that using a unified design database can speed up the build of a facility. This is the second reason, I believe, that we document in the first place. I like this quote by Damian Conway: "Documentation is a love letter that you write to your future self." And to me, this is just a reminder that if we take the effort and you have the diligence to keep track of the things that we're doing as we're doing them, our future self will thank us for that. Or maybe someone else that's responsible for operating or maintaining that system in the future. So as soon as we're done building the facility, the changes start, maybe even before we're done. And so change is just a constant reality of the constantly shifting media systems that we're building, especially as evidenced by all the things discussed in this room today. Things are constantly shifting. That includes hardware, that includes software and firmware. And what is necessary in order to keep different teams on the same page is to have a shared single source of truth. And this is an important aspect of this concept. So I've come up with a few qualifications for what is a shared single source of truth. Some of you may know, but I'm going to give it a few call out a few specific things. First of all, it is a centralized database with the most current data. So whatever is up to the date information is accessible to everyone in one place. So for example, if I have an Excel file on my laptop that you can't get to, that's not a single source of truth. Number two, visibility of the desired state. How do we want the system to be? How is it supposed to be? This is looking forward. Three is visibility of the current state. So an example of this is I want to install some decoders or servers, and so I add them to this design database, and I mark them as planned. So in that way, I am representing the current state and the future state. And the fourth thing is accountability of changes. And so this is just about knowing who changed what when, and that just, I think, raises the level of people that are working in this system, knowing that as they make changes to the design, that their name is attached to that change log. Jumping back to the story at the beginning, imagine if this person, this overnight operator, had been able to, had access to these tools, been able to, in the middle of the night, pull out their iPad or computer, scan the QR code, and be brought to a page showing the rack elevation. And instead of having to go shuffle through drawings to find the most current one, they would be able to, now this is going to show a version of what would be on the iPad. They're going to find the switch that has the issue. We're going to go and click on that switch, open it up, take a look at, say, the interfaces that are on that switch, and I'm going to jump back, and now I'm going to jump right to the drawing that this switch is on. So here's the most current version of the drawing. You can see there's two versions there, and now I can troubleshoot my problem. A very powerful way to communicate the current documentation and have a shared single source of truth. The next way that a unified design system helps with communication is with change management. As I'm sure you know, most large organizations like to have a change management system, maybe it's ServiceNow or something else, to make sure that the people making adjustments to the system are getting buy-in and being accountable for the decision makers. And what really enables the ability to have a good change management system is to have very accurate data about the state of the system that you want to change, so that the people that are requesting a change are able to say, this is what I want to change, this is how I want to change it. That's able to streamline the process of making that work, and not just another step that slows everything down. The third way that this helps with communication is with automation, automated deployments. So here's an example of a project that we very successfully implemented an automated configuration of switches directly from the database. So in this example, I'm going to select a switch, and as you can see, I'm going to go to the interfaces. This is going to trace all the cables across all those multi-segment cables. I'm going to hit build switch config, and it did in real time. It just generated this configuration based on the devices that are on the far side of all of these links, including some special settings. Maybe some of those device types have a rule that they need a FEC setting or a speed override, and that logic can be built into this template that's going to generate this switch config. And then, of course, this could be routed through ServiceNow or just deployed straight to the switch. And this was very successful to configure thousands of switch ports, all with IP addresses. This was a totally layer 3 network. And then including port descriptions, which is handy. So those are some of the ways that having a unified design database system helps with communication. The third way, or I should say the third reason that we build is to understand these systems. I'm sorry, the reason that we document is to understand these systems. And in this example, I think drawings are the best illustration of this. Drawings are very helpful when it comes to understanding of systems. When you start when you start designing a system, a big facility or media system, maybe you start on a whiteboard and you draw some boxes and some lines connecting those. Pretty soon those turn into system architectures that are still high-level sort of conceptuals. And all too often those drawings, those high-level drawings are lost to some cloud folder share, and they're not accessible to the people that end up being responsible for operating the systems, operators and engineers. And so one of the benefits of unifying the drawings with the rest of the underlying data and linking them together is that those users, people that are trying to understand the system that they're maintaining, are able to go see, okay, what's the big picture of this system, and understand the way that it's supposed to work at a high level. So now that I've said how great drawings are, and I do believe that they don't tell the whole story. There's a growing list of things that are really hard to represent on drawings, and just a few of those are IP addresses. There's not always enough room for all the IP addresses that you might need in a drawing. The VLANs, the virtual machines, power utilization, multicast IPs and managing those, WAN circuits, network address translation, the cloud. Obviously, so many things are moving to the cloud, trying to migrate to the cloud, and it's hard to capture all of the details of those things in a drawing. Of course, you still need a high-level drawing. This is the way the cloud's supposed to work, but you can't capture everything. So the best case, or the best way to go about this, is to have that high-level drawing and to connect it to the low-level data that's supporting it. And that is stored in the database in the form of IP addresses, clusters, all the things that you need to build something. It's in a virtual way in software. So linking those things together, drawings and the data that are beneath them, is a very powerful thing. So this is a view of just what a list of all the drawings would look like that we've added as a model to NDocs. And so you can have video drawings, audio drawings, a whole collection that we're used to having with a broadcast system. And by the way, I'm not here to say which drawing software is the best. There's a lot of options, and they all have their advantages and drawbacks. But the benefit, but what we can do is pretty much any drawing program is going to output a PDF. And so we're able to take that PDF from AutoCAD or Lucidchart or Visio, whatever, and add it into this unified database. And in this instance, you'll see that we're actually going to automatically scan the drawing, index it, make it searchable. All of the drawings are searchable. And then when I open it up, I'm actually going to create links from all of the key items. So for example, this is the name of a device. I can now click on that. It brings me to that device. If I want to see what is this model of this device, here's an example of, you see the front and the rear images. And then another example is fly-offs or pointers on drawings. It'll take you to that other drawing. No more manual looking and jumping between drawings. And all of those links are done in an automated way. So that's one of the main ways that we can promote understanding and the connection between the detail and the high level. So here we have another example. And as I said, I can't tell you what the best piece of software is to draw with, but AutoCAD is fairly popular. So this is an example that we made where we're actually closing the loop between the drawings and the data that's supporting the drawings. So as you can see here, Ethernet 13, port 13, there's nothing on that. I just clicked a button that said, download AutoCAD Script. This script downloaded, I dropped it onto this template in AutoCAD, and it did all the pointers, it did all the cable numbers, it named the device. It basically drew this drawing for me. And so that, with this way, you know that your drawings are in lockstep with your design. So there are also opportunities to do similar things. Visio has data import, and so does Lucidchart. So these are also possibilities for whatever drawing software ends up being used. So these are some of the ways that understanding can be promoted and why we document to understand systems. In conclusion, the 3 reasons that we document in the first place: to build media systems at scale, build them faster, more accurately, track the progress of those builds. We document to communicate the changes that are ongoing changes that are happening to those systems. That unlocks opportunities for infrastructure as code, automation, many improvements in efficiencies. And we document to understand by bringing the drawings into this database and linking everything together in a very useful way. So that is it. I would love to take some questions, and thank you so much for your time.
Oh. People are sprinting to the microphone. If you have a question, come on up to the mic.
Ciro Noronha, Cobalt Digital. Quick question. You built all this on an open source basis, right? Have you contributed the result to open source?
We have not been contributing to the upstream source, and for 2 reasons. One is the things that we've added are very unique to the broadcast industry, and they really don't have interest in integrating those things into this project. So early on, actually when we started doing it, there was no cables model. And I went and said, hey, I want to add cables to Netbox. Can we add cables? They said, no, we're not interested. I said, okay, never mind. And so they did add cables, they realized. And this is all I can say is that as we move towards a pure network media system, Netbox, in that world, Netbox will solve all of our needs. So I'm just trying to solve the broadcast-specific needs. Otherwise, Netbox has got you covered.
But you could always clone the repo, and then you could
What's that?
You could always clone the repo, and then you could fork it, and then you could, make your own branch for media.
And which is what we did, which is NDocs. No, and that is what we did.
Okay. So
he's asking if we contributed to the upstream project.
Okay.
And the answer is that there have been some minor contributions when they want it, but the greater IT industry doesn't care that much about the media industry and the multicast IPs that we want to track.
Yeah, I think we got that. Cyril.
Yeah, but so is cloning the repo and publishing it, have you done that? I mean, if I wanted to use this, is it available somewhere?
NDocs is not available right now. No. Netbox is, and pretty much everything that you saw today.
You guys should make that available, because there's thousands of billable hours in actually populating what you showed.
Yeah.
So from a business standpoint, you got tons of money to make. Why not clone the repo?
Let me put it this way. There's been a lot of discussions about how to handle this. And I've only been at Deloitte for a year, and I'm figuring out how that can work. But pretty much everything I showed you today, you can do with the open source version of this.
Okay.
Most of the things I showed you.
But still, I bet you could go to like your grand boss and say, look, we're making our money on the billable hours to populate this thing, not on this tool. Why don't we open source it? And then all these people in this room where I made this presentation would have had a lot of love.
It's a very good suggestion, and it's definitely something we're considering.
Just something to think about.
Hi, Lucas. Do you automatically use NDocs with every job you do now, or is that something you charge extra for?
So far, we've been doing it mostly on sort of as you said, the billable hours is more important, right? The actual build and getting that right. So we haven't had a line item, we're going to charge you this amount of money. And we haven't been using it for all projects. The project, the uplink facility that I'm talking about has not adopted it, right? I think it would benefit to index all those drawings, make them searchable. I think that would be great, but I'm taking it one step at a time. So the projects that I'm involved in, and there's about 5 right now that are using it, and to varying degrees in terms of like how far along we are. And so any project I'm involved in, but there's a lot of projects and I'm not involved in all of them.
So they have to integrate with their asset management system and everything to use the QR codes, for example?
So, yes, I was, the project that I gave that example of, they were kind of like, we don't really have an asset management system. They were just trying to figure it out. So we were able to give them at the end of the project, and they continued to just use it. But you could just also just have an export. Here's all the devices, all their locations, their asset tags, their serial numbers, and move it over. Or you could build an integration. I mean, it would certainly not, it shouldn't be that hard to build the integration if you know, you wanted to integrate with a more traditional asset management system.
Great. Thanks.
Yeah.
That's pretty cool.
You're welcome. Thanks.
Great. Well, I think when you gave this presentation at the SMPTE, I think I was right after you, if I remember. And I got up and said, I'm a big fan of documentation from way back, and I really am. And I also recognize that every integrator, whether it's you guys, you know, it's Diversified DB, whoever, they have their own documentation tools and their own way of working. But I think that there is a general problem for the industry, as you've identified, and I'm a big fan of, where you know, people that aren't going to be able to spend the amount of money that it's going to take to bring in NTC or Diversified or DB or somebody else still have a serious documentation problem. And I mean, it's a big lift, right? To put this out there, then like there's documenting how you use the documentation system, and that's not free, right? But you might get a community of people that would be interested in supporting this, and who knows, you might get some ideas that would be things that you would say, wow, we didn't think of that. We'd incorporate that in our in-house stuff. So anyway, it's something to think about, and it's really a big problem.
I am a big fan of open source, and I want to do things that contribute and everyone can benefit from. I want everyone to be able to build efficient systems. Yeah, the good news is that Netbox does a lot of the things that need to get done. So I think if you start with that, you'll find that it has an extensible data model right within it. You can add custom fields. If you want to say, oh, I want to define a signal on a device or on this interface or IP address, you can add it right within the GUI. No forking at all. So the things that we've done are sort of a little icing on the cake. If I'm honest, we've definitely learned how to use these tools pretty well, but I think most of it's out there. The tools are there, and yeah, I'd encourage you to use them.
Yeah, the stuff that you've done, though, see, I'm not going to let him go that easy. The stuff that you've done, though, is media specific, and I think you can argue to your grand bosses that, you know, this adds value to your brand in the industry, and the whole bit about building a community around open source, I'm a believer in it, too. So anyway, you can tell them, when you get back, you can tell them, I took a little heat on this.
Yeah.
What, couldn't we just, like, throw a bone? Anyway, something to think about.
Yeah.
Go ahead.
So Adam Salcombe with Diversified. More a comment than a question, but it's related to some of your automated tools. So of course, Diversified is also looking at all sorts of tools to improve efficiency. One thing that we've struggled with is that an automated tool that gets it right 90% of the time and silently fails or creates errors 10% of the time is worse than no tool at all. And so one of the things that we've always tried to do is like, can you have an automated tool that does 90% of the things correctly, and then the 10% it just flags and says, like, you know, like, please look at these separately. And I don't know whether you've had a similar type of experience.
I mean, yes. My preference would be to try and figure out why that 10 or 20% failed and go back and fix it in the automation. But you're right, that can be a blocker, and you need to fix something now, and so you're just gonna fix it. Maybe I'm struggling to think of what exactly the example where something would fail. I still think, you know, I'm using the word automation, meaning it generated that script, or, you know, the configuration on the switch. Someone is still going to scan through that and check it. They're not going to press it. And we actually, the client in this instance, they said, well, maybe we should just put a deploy button there. And after we talked about it, it was like, no, we don't want to make it that easy. We want someone to look at it and someone to approve it and then someone to write that configuration. So maybe that answers your question?
The sort of example that I'm thinking of is like, we've gone back and forth between, you know, for example, automating, you know, the whitelisting,
yeah.
you know. And very often on large projects, we actually find it better to hand the drawings over to our install supervisor who manually wirelists, which seems like a terrible, old-fashioned way of doing it. However, it comes with some advantages. First of all, they catch errors or things that are simply unclear. So, the engineers are creating the drawings a mile a minute. You might have multiple engineers and they've got fly and fly offs between different drawings from different engineers. The install soup gets the set of drawings, they're going through, they're trying to understand the drawings. And it's like, hold on, this doesn't quite match up. Or it might actually match up, but it isn't completely clear. And so then that's a real benefit for us to have that second set of eyes essentially evaluate the drawings. They can catch the errors, they can catch the things which are unclear that need more detail on the system in a way that most automated systems simply don't do. And the other benefit we find by doing that is that by the time the install supervisor has done all of that job, they know the system before they ever go on site. So that's the sort of like things, things we've been balancing.
Good points. And I mean, maybe I should just say, and this was part of a talk previously, which is just a point that we're still going to need good engineers. You still need engineers to design and figure this stuff out. There's not really, this is just about having tools to help them be more efficient and not just do these like tedious things, right? I think trying to move away from tedium. You still need engineers to do work. That's for sure.
I agree. I sort of like think of tools as being sort of like a cordless, a cordless screwdriver, battery, yes, you can pick that up and you can use it, or, hey, that doesn't work for me, I'm going to get out my hand screwdriver. That it shouldn't be you've always got to use the power tool. You've got to have the capability of going back and say, no, in this case, I'm going to bring out my standard screwdriver and use it. And that's something, I think, the problem I've seen with a lot of these automated tools is that it only gives you one way of doing it, and you can't go and, sometimes it makes it hard to do it manually, even when the manual operation is a better way to go.
Yeah, good thought, so thanks.
Yeah, thank you. A couple of other things real quick just on this topic. For more kind of another look at doing this, you could take a look at the work that CBC Radio Canada has done around documenting and actually blowing down configs and whatever to thousands and thousands of SFPs and devices and switches. And shameless plug, that's in the SMPTE, in the October issue of the SMPTE Journal, which I was the editor for, which contains a bunch of other articles, one of which is an article Jim Traynor wrote on the single source of the truth, and CI/CD, and a bunch of other concepts that all kind of flow into this. So that would be something for you guys to look at. The other comment generally I have coming from the operations side in a large media facility is garbage in, garbage out. And with any of these systems, they're great tools, but if you don't have controls to be sure that the information that gets into it is good, then, it's bad information in there, and sometimes this stuff gets copy-pasted all over, and that's can be something that can bite you. So it's just something to watch out for.
I mean, you're totally right, but compared to, say, a spreadsheet, this
yeah.
is going to highlight a duplicate IP address. No,
Yeah.
this IP has already been used. Highlight 2 cables connected to the same port. No, this port's already taken with this cable. So there's a lot of just basic checks that can be really useful. But you're right, if you put in a bunch of garbage, if you were to load that up with lots of incorrect drawings and make them indexable, they're not going to be any more useful than, that's not going to help anyone.
Right, but on the other hand, if you put the effort into this, it's, I can't say how, and I said this at the SMPTE conference, I cannot say how important and enabling this is, not just for integrators, but also for the handoff to the people that are actually going to operate these facilities going forward. I believe it is a substantial investment, and you have to guard for that, and you have to take the time to build those kinds of tests and other things into this tooling. But that pays huge dividends, maybe not even as much for the integrator as it does for the people that are actually operating the facilities after you've done the handoff. So anyway, big fan. There's a lot to talk about here. Thank you.